High-voltage electrical equipment contains immense amounts of energy. In the event of a failure, this energy can be released catastrophically. Contact with high-voltage electricity can cause severe burns, electrocution, and death. The resulting explosion and fire can also cause damage to surrounding areas and equipment. It is critically important to always obey safety protocols and warning signs when working near high-voltage equipment. Maintain proper grounding and insulation to prevent electrical faults. Regularly inspect and maintain electrical equipment to ensure its safe operation. Never attempt to repair or handle high-voltage equipment without proper training and authorization. Keep the area around high-voltage transformers clear of flammable materials and potential ignition sources. Should a high-voltage transformer failure occur, evacuate the area promptly. Contact emergency services immediately. Notify the fire department, police, and utility company. Secure the area to keep people away from the damaged equipment. Cordon off the area to prevent unauthorized access. Do not touch the equipment. High voltage electricity can remain present even after the power has been shut off. If the transformer failure resulted in a fire, ventilate the area to remove smoke and fumes. Be aware of the potential hazards of high-voltage electrical equipment and take appropriate precautions. Respect the power of electricity and never underestimate its destructive potential. Educate yourself about electrical safety and follow best practices to avoid accidents and injuries. Prevention is key when dealing with high-voltage systems. A robust safety program is crucial, beginning with comprehensive training for all personnel who work near or with high-voltage equipment. This training should cover the identification of hazards, the use of personal protective equipment, proper grounding techniques, lockout-tagout procedures, and emergency response protocols. Regular inspections are vital for identifying potential problems before they escalate into failures. These inspections should include visual checks for signs of damage such as cracks, corrosion, or leaks. Additionally, electrical testing should be performed to assess the condition of insulation, connections, and other critical components. Maintenance is essential for ensuring the continued safe operation of high-voltage equipment. This includes cleaning, lubrication, and the replacement of worn or damaged parts. All maintenance work should be performed by qualified personnel following established procedures. Grounding is a critical safety measure for high-voltage systems. Proper grounding provides a path for fault currents to flow safely to ground, preventing dangerous voltages from building up on equipment or structures. Grounding systems should be regularly inspected and tested to ensure their effectiveness. Insulation is another essential safety measure for high-voltage systems. Insulation prevents electrical current from flowing where it is not intended, reducing the risk of shocks and short circuits. Insulation material should be selected based on their ability to withstand the voltage and environmental conditions to which they will be exposed. Personal protective equipment, or PPE, is vital for protecting workers from the hazards of high-voltage electricity. PPE includes items such as insulated gloves, sleeves, and footwear, as well as arc flash suits and face shields. The selection and use of PPE should be based on a thorough hazard assessment. Lockout-tagout procedures are used to ensure that high-voltage equipment is energized and isolated before any work is performed on it. These procedures involve placing locks and tags on energy-isolating devices to prevent the equipment from being accidentally energized. Emergency response planning is essential for minimizing the impact of high-voltage equipment failures. Emergency response plans should include procedures for evacuating personnel, contacting emergency services, and securing the area. The plan should also identify individuals responsible for coordinating the response. Firstly, always maintain a safe distance from high-voltage equipment. The distance depends on the voltage level, but the general rule is to stay at least 10 feet away from exposed high-voltage conductors. Secondly, never enter a substation or other area containing high-voltage equipment unless you are authorized and trained to do so. Thirdly, always assume that high-voltage equipment is energized even if it appears to be de-energized. Fourthly, never touch any high-voltage equipment unless you are qualified and authorized to do so. Fifthly, use appropriate personal protective equipment, such as insulated gloves and sleeves, when working near high-voltage equipment. Sixthly, follow lockout-tagout procedures to ensure that high-voltage equipment is de-energized before any work is performed on it. Seventhly, be aware of the potential hazards of arc flash and take precautions to protect yourself. Eighthly, report any unsafe conditions or incidents involving high-voltage equipment to your supervisor. Ninthly, participate in regular safety training to stay up to date on the latest safety procedures. Tenthly, if you are not qualified to work on high-voltage equipment, stay away and call for help. High-voltage transformers are essential components of electrical power systems, but they can also be hazardous if not handled properly. Understanding the risks associated with high-voltage transformers and implementing appropriate safety measures can help prevent accidents and injuries. Transformer failures can be caused by a variety of factors, including insulation breakdown, overheating, lightning strikes, and mechanical damage. When a transformer fails, it can release a large amount of energy in the form of an explosion or fire. This energy can cause serious injuries or fatalities, as well as damage to surrounding equipment and property. There are several steps that can be taken to prevent transformer failures. Firstly, regular inspections and maintenance are essential. This includes visual inspections for signs of damage, as well as electrical testing to assess the condition of the insulation and other components. Secondly, transformers should be protected from lightning strikes with surge arresters. Surge arresters divert lightning currents to ground, preventing them from damaging the transformer. Thirdly, transformers should be operated within their rated capacity. Overloading a transformer can cause it to overheat and fail. Fourthly, transformers should be properly cooled. Overheating is a major cause of transformer failures. Fifthly, transformers should be protected from mechanical damage. Mechanical damage can compromise the insulation and other components of the transformer, leading to failure. In the event of a transformer failure, it is important to evacuate the area immediately and call emergency services. Do not approach the transformer until it has been energized and declared safe by qualified personnel. High-voltage electricity is a powerful force that can cause serious injuries or fatalities. It is important to respect the power of electricity and take appropriate precautions when working near high-voltage equipment. Firstly, always assume that high-voltage equipment is energized. Secondly, never touch any high-voltage equipment unless you are qualified and authorized to do so. Thirdly, use appropriate personal protective equipment, such as insulated gloves and sleeves, when working near high-voltage equipment. Fourthly, follow lockout-tagout procedures to ensure that high-voltage equipment is energized before any work is performed on it. Fifthly, be aware of the potential hazards of arc flash and take precautions to protect yourself. Sixthly, report any unsafe conditions or incidents involving high-voltage equipment to your supervisor. Seventhly, participate in regular safety training to stay up to date on the latest safety procedures. High-voltage safety is not just a set of rules and procedures, it is a mindset. It requires a constant awareness of the hazards involved and a commitment to following safe work practices. By taking the necessary precautions, you can protect yourself and others from the dangers of high-voltage electricity. One important aspect of high-voltage safety is understanding the concept of arc flash. An arc flash is a dangerous electrical explosion that can occur when there is a fault in a high-voltage system. Arc flashes can generate intense heat, pressure waves, and toxic gases. They can also cause severe burns, blindness, and hearing loss. To protect yourself from arc flash hazards, it is important to wear appropriate personal protective equipment, such as an arc flash suit, face shield, and gloves. It is also important to follow safe work practices, such as maintaining a safe distance from energized equipment and using insulated tools. Another important aspect of high-voltage safety is understanding the concept of grounding. Grounding is the process of connecting electrical equipment to the earth. Grounding provides a path for fault currents to flow safely to ground, preventing dangerous voltages from building up on equipment or structures. It is important to ensure that all high-voltage equipment is properly grounded. Grounding systems should be regularly inspected and tested to ensure their effectiveness. Lockout-tagout procedures are used to ensure that high-voltage equipment is energized and isolated before any work is performed on it. These procedures involve placing locks and tags on energy-isolating devices to prevent the equipment from being accidentally energized. Lockout-tagout procedures should be followed every time work is performed on high-voltage equipment. Emergency response planning is essential for minimizing the impact of high-voltage equipment failures. Emergency response plans should include procedures for evacuating personnel, contacting emergency services, and securing the area. The plan should also identify individuals responsible for coordinating the response. Regular safety training is essential for ensuring that workers are aware of the hazards of high-voltage electricity and how to protect themselves. Safety training should cover topics such as hazard identification, personal protective equipment, grounding, lockout-tagout procedures, and emergency response planning. Safety training should be conducted regularly and should be tailored to the specific hazards of the workplace. High-voltage safety is a shared responsibility. Everyone who works near or with high-voltage equipment has a responsibility to follow safe work practices and to report any unsafe conditions or incident. By working together, we can create a safer workplace for everyone. In addition to the above, consider the following points for improving safety around high-voltage transformers. Firstly, implement a robust permit-to-work system. This system ensures that all work on or near high-voltage transformers is properly planned, risk-assessed, and authorized before it commences. The permit should detail the scope of work, the hazards involved, the control measures to be implemented, and the personnel authorized to carry out the work. Secondly, regularly review and update safety procedures. Safety procedures should be reviewed and updated regularly to reflect changes in technology, regulations, and best practices. This ensures that the procedures remain relevant and effective in protecting workers from hazards. Thirdly, conduct regular safety audits and inspections. Safety audits and inspections should be conducted regularly to identify potential hazards and ensure that safety procedures are being followed. The findings of these audits and inspections should be used to improve safety performance. Fourthly, promote a strong safety culture. A strong safety culture is one in which safety is valued and prioritized by everyone in the organization. This culture is fostered through leadership commitment, employee involvement, and continuous improvement. Fifthly, investigate all incidents and near misses. All incidents and near misses involving high-voltage transformers should be investigated thoroughly to determine the root causes and prevent recurrence. The findings of these investigations should be shared with all relevant personnel. Sixthly, use technology to improve safety. Technology can be used to improve safety in a number of ways, such as through the use of remote monitoring systems, automated switching devices, and personal protective equipment with enhanced features. Seventhly, provide ongoing training and education. Ongoing training and education are essential for ensuring that workers stay up to date on the latest safety procedures and technologies. Training should be provided on a regular basis and should be tailored to the specific needs of the workers. Eighthly, engage with stakeholders. Engage with stakeholders such as equipment manufacturers, industry associations, and regulatory agencies to stay informed about the latest safety developments and best practices. Ninthly, learn from others. Learn from the experiences of others, both positive and negative, to improve safety performance. Share your own experiences with others to help them avoid similar incidents. Tenthly, never become complacent. Complacency is a major cause of accidents and injuries. Always remain vigilant and focused on safety even when performing routine tasks. By implementing these measures, you can significantly improve safety around high-voltage transformers and protect workers from the hazards of high-voltage electricity. Remember that high-voltage safety is an ongoing process that requires continuous attention and improvement. Never take safety for granted, and always be prepared for the unexpected. Consider also the design and layout of high-voltage transformer installations. Firstly, ensure adequate spacing between transformers and other equipment. This helps to prevent the spread of fire and explosions in the event of a failure. Secondly, provide adequate ventilation to prevent overheating. Overheating is a major cause of transformer failures. Thirdly, install fire suppression systems to quickly extinguish any fires that may occur. Fire suppression systems can help to minimize damage and prevent injuries. Fourthly, provide secondary containment to contain any oil spills. Oil spills can contaminate the environment and pose a fire hazard. Fifthly, install perimeter fencing to prevent unauthorized access. Unauthorized access can lead to vandalism, theft, and accidents. Sixthly, provide adequate lighting to improve visibility. Adequate lighting can help to prevent accidents and improve security. Seventhly, locate transformers away from sensitive areas such as residential areas and hospitals. This helps to minimize the impact of any potential failures. Eighthly, design installations to be easily accessible for maintenance and repairs. This helps to ensure that equipment can be properly maintained and repaired in a timely manner. Ninthly, use durable and weather-resistant materials. This helps to ensure that the installation can withstand the elements and remain safe over time. Tenthly, regularly inspect and maintain the installation. Regular inspections and maintenance can help to identify potential problems before they escalate into failures. The NEC or National Electrical Code contains many articles and tables applicable to high voltage installations. NEC Article 450 covers transformers and transformer volts. Article 490 covers equipment over 600 volts nominal. NEC Table 310.16 provides ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius through 90 degrees Celsius.